Hello, are you able to hear me?
Yes, sir.
Okay, so hi Kiran, we'll just wait for a couple of more minutes so others will join and then after we'll start this session.
Okay, sir.
By far, if you have any question or something, then you can ask. Meanwhile, others will join. So we will wait for a couple of more minutes by 6:05 and then after we'll start this session. So I think one of you have told me to prepare how to prepare map in QGIS. So I think we have covered that in the previous lecture. So if you have not attended that lecture, then you can just go through that. And if you have any other question further after going through that module, you can revert back to me in the next problem solving session. Meanwhile, do you guys have any other question? Then please let me know. So I think we can start now. So as hello everyone, my name is Hiren Solanki and I am conducting your problem solving session for this course on Geographic Information System from NPTEL, or which is being taught by Professor Arun K. Saraf. So here, as we discussed or we did in the previous classes as well, first we will discuss some of the question answers from the previous week. So week number 4, which is covering the pre-processing and some steps about the spatial interpolation. And then after we will see some of the websites to download the data set. Today particularly we will learn about the groundwater data set, and then after we will see how to use these data sets into QGIS. Basically, we'll do the interpolation part today, and if time permits, then other things we will also do. Okay, so with that, let's start today's module. In between, if you have any question, please unmute yourself and ask. Also, if you have anything else to ask regarding the classes or previous week video sections, then also you can unmute and ask. And We will solve some question answers first, so please unmute and try to answer the questions if you know the answers, or if you don't know, then just guess something and we'll figure it out whether it's right or wrong. So with that, let's start today's session. Uh, so welcome everyone. Okay, so our first question is, a researcher measures the distance between two cities, Delhi and London, using the geographic coordinate system without any projections. Now focus on the two statements which are given here. Planar measurements true would provide the true shortest path, and geodesic measurement considers the ellipsoidal shape of the earth. So which of the following is right here?
Option C, sir.
Yes, let's check it out. So option C is not, both are not correct. Okay, so here see, planar measurement would provide the true shortest path. So like here the thing is we are using the geographic coordinate system, not the projected coordinate system. And that's why the something which looks shortest, if we see it on curve, it might be appear different also. So here the condition is we are not using any projection. If it is a projected coordinate system, then it might be true. Okay, so option number first is not correct. Only the second option is correct. Okay, is that fine? Okay. Uh, in between, still, if you don't get anything, just unmute yourself and ask. So the next question is, which of the following is true regarding the loxodrome and great elliptic paths? So loxodrome maintains constant azimuth or bearing. A great elliptic line is always longer than loxodrome. Great elliptical becomes great circle on sphere. So option A in 1 and 3, 2 and 3, only 1, or 1, 2 and 3. So here, if you don't know, you should go through the terminologies which are given in the course itself. If you don't want to go through the entire lecture series as well, then you just go through the PPTs which are given. So these definitions are clearly being highlighted in the classroom PPT as well. And these terminologies are very necessary. So when we talk about Luxotome, then it's a line with constant bearing or azimuth, we can say, and that's why the distance might be high, and that is useful when we use these geographical coordinate systems or degree minute seconds when we are using the routes by say like sailing or flight. So if you go through this, I mean, these lectures are also being done in this pre-processing spatial data sets part 1. Those things are given, so it's kind of highlight. um, so you can read about these terms: plan, geodesic, and then loxodrome and great elliptic. So these four are very useful when you want to measure the area and distance in the GIS datasets. And this will be a very common applications while working with the GIS. So here, if you focus on loxodrome, then it's a not the shortest distance between 2 points, but it defines the line of a constant bearing or azimuth. Whereas great circle routes are often broken into series of loxodrome, which is means being constant bearing, then which will simplify the navigation which we do by flight or by sailing in the like boats. So this is also known as a rump line. And then when we talk about great elliptic, then this line is on the spheroid or ellipsoid. So spheroid is the actual surface of earth, and the ellipsoid, we can say it's a mathematical surface defined by the intersection at the surface by plan that passes through the center of the spheroid and the start and end point of the segment. And this is known as a great circle like this when we use the sphere rather than spheroid. So based on this thing, can you tell me which one of the following is true? So option A, 1 and 3 is correct here. The next question is aspect of a raster cell is 270 degree. This implies a slope faces east, slope faces west, a flat terrain, undefined direction. So aspect shows the direction of the slope. Yeah.
Option B, sir.
Option B, slope faces west. Okay, anyone else?
Option B.
Yes, so let's get and check. So B is the right answer. So these are the angles with respect to north, where the north is 0 degree. So when you go for south, it's 180 degree, then 270 degrees, 90 degrees east, and 270 degrees west. Now, can anyone tell me what is the applications of aspect? Why do we need aspect?
Direction of slope, sir.
Yes, so if we know the direction of slope, in which kind of application it will be helpful to us? So I think in the classes you have heard about the application for soil erosion, how the rainfall is, water is moving, or you can say about how snow is melting and so on and so forth. So basically, if in Himalayan regions or like say if you have hill like this, that hill is like this, and then all the water or you can say rainfall is coming in the area like while it is colliding with the that particular hill and the behind region will become shadow region. So here like if the slope is facing towards the southward or you can say the southwest side or west side, then this all the water will come in the downstream of the Himalaya. Okay, so based on that we can think of that if what direction of the slope, if like if in Himalayan region if the slope is towards the southern side, then it will affect the high erosion or it will helpful in the snow melting. And similarly if we go to the western ghats, then water sorry rainfall is going in this direction towards the western ghats and the parts of the southern India. So in that case, like say if your slope is in the western side or the southwestern side, then it will create the more uh, slopiness, and then more water will flow in that direction and it will directly go to the west coast. So similarly, like if you want to implement solar panels, then also this will be very useful. Yeah. So the next thing is in a slope calculation from a DEM. Statement 1, slope is computed using only 4 neighbors. Slope can be expressed in percentage or degree, in percent or degree. Which of the following statement option is right? Only one, two, both, or neither?
B.
B. Yes, so generally when we calculate slope, we use all the 8 neighbors, and that's why the first statement is incorrect. Yeah. The next question is, if rise is equal to 50 meter and run is equal to 100 meter, percent slope equal to
Option B, sir.
option B.
B.
So how much rise we have, and with respect to that, what much run we have. Okay, so 50 by 100, so we'll get into by 100, so 50%. Which of the following is not pre-processing step? Edge matching, rectification, kriging, or format conversion?
Option C, sir.
kriging is a processing step. Once we collect the point data, then we convert it into raster purpose. Okay, sorry, rectification. Kriging is also pre-processing step. Sorry, to generate the data sets. Rectification, there is no such step such as rectification. We have the step of generalization, data generalization, rather than rectification. So there is no terminology such as rectification. Okay. Next one is edge matching primarily ensures projection consistency, seamless boundary alignment between the adjacent dataset, attribute normalization, and DEM smoothing.
Option B, sir.
Now moving towards the next question, we have in data generalization step, removal of extraneous bands while preserving the shape refers to the smooth line, simplify line, aggregate polygons, and thin road network. So
Option
I
B, sir.
think yes. So you will get to know from the option only most of the things, and you can read more about these generalization methods if you go to the PPT, and there is one table provided at the end that what kind of data generalization we do. So aggregate point, aggregate polygons, collapse road details. So you can read more about like what does that term of type of generalization means. So basically here we have simplify line, which is simplifying line by removing the extraneous bands while preserving the essential shapes. And when we talk about simplify polygons, it's by removing the extraneous bands while preserving the essential shape. Both are similar to only, but one is for line, one is for polygon, and simplification is preserving the shape. And when we do the smoothing, so then smoothing, it will happen mostly at sharp angles in the line, which will improve the overall aesthetics and cartographic quality of the lines rather than preserving the shape. So you can read more about the data, various kinds of data generalization. Now the next one is which operator creates center lines from dual carriageway roads. So merge divided roads, collapse dual lines to center line, thin road network, and aggregate points.
Option B, sir.
Yes, so collapse dual lines into center line. Next is generalization is described as a holistic because it follows strict mathematical rules, it is subjective and scale dependent, it removes projection distortion, and it is automated. So if you think about it's like when we do the generalization, it's a more of subjective side because we do not know what we are doing. So generalization is an holistic process due to its subjective nature and the lack of well-defined rules. So because of those two issues, it is just a minute. Let me add the other people joined. Okay. Okay. So the answer here is it is subjective and scale
B.
dependent. Next is increasing map scale from 1 raised to 1000 to 1 raised to 27,176 will increase detail, reduce detail, not affect details, or increase accuracy.
B.
B. Reduce details. Anyone else? So I think what I can show you one picture which sir has also showed in class. You can focus on this image. So how the scale is changing, and with respect to that, what is happening. So things are becoming like if the 1 raised to n, if n is increasing, then the scale is becoming less. So here, like if it will become very small in the same space, then what will happen? It will reduce the details. So you were correct. Now next question is image fusion combining PAN and LIS3 improves spectral resolution only, spatial resolution only, both spatial and spectral resolution, and temporal resolution.
Option C, sir.
Yes, so we can improve the both spatial and spectral resolution. How we can improve spatial resolution? By using the pen sharpening, where we are converting this 23.5 meter imageries to visualize as a 5.8 meter high resolution imagery, thus increasing the spatial resolution. And in this similar way, we are getting some additional bands which are coming from PAN, so that we use as a RGB, placing different bands. So that's why it's increasing the spectral resolutions as well. The next question is pseudo-color transformation (PCT) in earthquake damage assessment is primarily used for radiometric calibration, visual change detection, georeferencing, and edge matching.
Option B, sir.
Yes, so those are useful for the visual change detection. In one image, we will consider the pre and two post, and in another one, we will use two post and one pre image. And based on that, we will get to know, we'll do these pseudo color transformations, and then we will analyze the which area is affected by the earthquake. So, I mean, like I will try to show the similar examples from the slides as well, along with we are moving towards the MCQs so that you will get more understanding of it along the way. So here you can see the example. Just let me make it big. So here, I mean, when we do this thing like pre-earthquake image and post-earthquake image, and then we'll use some part from pre-image and some part from post-image, we will can represent the affected area by this red color, which is known as a pseudo-color transform image, and which will give us the area which is affected by the earthquake. And this will be just visual interpretation rather than the actual thresholding and quantification. And if you want to do it further, we can mark it out, make a digitized polygon boundary, and then we can do the further analysis. So this is a visual change detection part. Next. Uh, which interpolation method is local, exact, abrupt, and deterministic? A kriging, IDW, Thyssen polygon, and trend surfaces.
Option C, sir.
C, which is Thyssen polygon. So that is a proximal method which is local, exact, abrupt, and deterministic, which we use in mostly in hydrology most of the time. Okay, any doubt till this point? Now moving to the next question, we have according to the Tobler's first law, which of the following is correct? All points are equally corrected. Distant points are more related. Nearby points are more similar than the distant point, and correlation is random.
Option C, sir.
Yes, so if the point is nearby, then it will have more kind of information, and that's why it will give more information to us. So option C is correct. Which interpolation type determines one function across entire region? Global, local, exact, and proximal.
Option yes, sir.
Yes, so the global will give us the one function across the entire region. Local will see the applied in the different parts, and then it will give the interpolation. Whereas exact, it's like similarly the same value we'll get when we do the interpolation, and proximal is like kind of Thyssen polygon, which we see. Now, when we talk about IDW, inverse distance weight, it assumes influence decreases with distance. Power parameter controls weighing scale strength, and it should be stochastic. It is stochastic, sorry. A in 1 and 2, B 1 only, C 2 and 3, and D all. So first of all, inverse distance weight, like the more the distance, we will give the lesser the weight. So the influence decreases with distance. So option number 1 is correct here. Now power parameters, like the which distance we are considering, like at which scale. So which will be like power of 2, 3, 4. So it will control the weighting strength. And third, so that is also true. And the third one is a stochastic. So I think we'll get just one value, and that's why we can say it as a deterministic. So to know more about the power parameters, let's say we'll move to the lecture slides also. Just a minute. Let me add people. Yeah. So we got this. Okay. So this is under the second lecture, where we see the inverse distance weight method. And here if we see that it will give the distance based on the uh, how far the point is from each other. Now here we consider this power factor which is given here. So this power controls the significance of known point on the interpolated value based on that weight distance from the output point. So higher the power means like it will place more emphasis on the nearby point, and if our power is low, then it will consider the larger perspective, resulting in the smoother surface rather than the exit surface. And then we talk about in this only, then we can apply this radius, search radius, or like either we can apply the search radius in how many area we want to search, or else we can provide the number of points. So based on that we can define this how spatial correlation is there. So those things we can see. So here the correct answer is first and two. It's not stochastic because it not gives the error estimates. It's a deterministic. It will give just one value at the given location. Now let's say we have this numerical, that we have point number A 10 and weight is 1, B 20 meter, and this uh, like D value is 2, and then C is 40 meter and D is 4. So using the IDW with power 2, predicted value will be how much? So this D is equal to 1, 2 and 4 are the pixel value which we have. And the first thing 10 meter, 20 meter and 40 meter are the distance from the point. So you can apply the formula of inverse distance weight, and we
Bhujal,
can, yes, yes, any question?
no sir, no.
Okay, so the formula, if you do not remember, I will just tell you. So the value is equal to summation of like your value divided by the weight square and divided by all divided by 1 upon I can show you here so that you can get the more idea. W. Yeah. So this is the formula of inverse distance weight. See this, you can just apply this formula here. So here the power is 2. Okay, we have 2 power, Then Z value is given for us, and this D value is also given to us. So based on that, you just do the calculation and let me know what will be the answer. Yeah. So we have 1 divided by 10 square plus 2 divided by 20 square plus 4 divided by 40 square divided by 1 upon 10 square plus 1 upon 20 square plus 1 upon 40 square.
One point 33.
Yes. Okay. Okay. So you just apply that formula. Next question is, if you have any doubt. Okay, fine. Um, Further, I just repeat the formula. What you have to do is, the value is equal to summation of 1 to n. So here we have 3 point. You have z and d distance was given also. So you just say distance, and this power is p is power, which is in our case we have to take 2, and 1 divided by distance square. Okay, so you just apply this formula and do the calculation. Now next question is, increasing IDW power will produce smoother surface, increase influence of distance point, increase local details, and mark surface stochastic.
Option C, sir.
Increase local details. Yes. So it will more, like if we increase the power, it will more become highlight on the nearby point. Okay, and because of nearby point, it will increase the local details rather than focusing a smoother surface. So here, if decreasing IDW power will be, then option number A was correct. Increasing IDW power means increasing local details. And it is decrease the influence of distance point and increase the influence of nearby point. Okay, in other words, if you want to tell the same thing. Next one is barrier in IDW interpolation method eliminates all distance point, restrict search to same side of barrier, converts method to kriging, and reduces power.
Option B, sir.
Yes, so let's say if some cliff or something is there and we are doing interpolation in the part of ocean, like let's say considering the water quality, and if some barrier came and then on top of that particular side one another lake is there, there also we have quality data. So during those kind of thing where the actual topography is changing, or if some actual barrier is there, we have to provide this barrier so that while doing the interpolation it should not cross that line while collecting the data. Next question is, regularized spline produces. So there are two kinds of spline, which are, one is the regularized one and one is the tensioned one. So I will just show you some details, I think, so you will get more idea about it. So here if we see, there is two types of spline methods are there in the GIS platform. One is regularized and tension. A regularized method, it will create smooth gradually changing surface as the name suggests, with the value which may lie outside the sample data range as well, while the tension method controls the stiffness of the surface according to the character. So one is more flexible, then one is a more stiff. and it creates a less smooth surface with the value closely constrained by the sample data range, and here it will go above the sample data range as well. So with reference to that, now tell me which of the following is the correct answer.
Option C, sir.
Yes, so correct answer here is a very smooth surface, possibly outside the data range as well. Tension spline weight increases, like tension spline weight increases causes smoother output, coarser output, exact interpolation, and reduced curvature.
Option B, sir.
Coarser output, is that fine? Anyone else? Okay, fine. Everyone also try to participate and try to give answer. If you don't know, if you want to revisit, just let me know. I can show the slides as well, so you can go to just look into it and then we can say. Which interpolation is stochastic and uses semi-variogram? IDW, spline, kriging, and trend surface.
Option C, sir.
Yes, so kriging is the interpolation which creates a semi-variogram first, and based on that it does the interpolation. A regionalized variable consists of structural component, spatially correlated component, and random noise. A in 1 and 2, B 2 and 3, C all, or D only one. So this is regarding the kriging, where we have regionalized variable which consists of what? So I can show you something. So this is the way, like when we do the kriging, it is based on the concept of regionalized variable that has three components. One is the structural component, which you can see as a red line, and which will represents the overall data or overall trend. Then the another thing is this green line, which will create the data often exhibit the positive spatial correlation. And then there is a random noise, which you can show by the blue dots which are given there. Okay, so which will show the measurement error and other errors. So here the correct answer is all three. Option number C. Next is semi-variogram models. What? Mean trend, square difference versus distance, probability density, and frequency distribution.
Option B, sir.
Square differences versus distance. Next question is exact interpolators smooth out original points, pass through known data points, always stochastic, and are global. So what is exact? So we have two things. One is exact interpolation and the another one is what? Anyone? So one interpolation method is exact and the another one is the approximate method. So exact, you can see here it's honors the input data. So whatever the input data we will have, it will try to keep the same value of the input data. Whereas in approximate, it will allow some of the uncertainty, because if we have just 10, it will not show exact 10. It will show some of the variability into that. Server joined. Okay. Okay. Now the next question is, so what will be the answer here? It's passed through the known data points. Tin differs from grid because of Team stores multiple Z per XY. Team uses irregular triangles. Grid is vector, and team cannot model terrain.
Option B, sir.
Yes, team uses irregular network. Next one is grid surface is called functional surface because of it stores many Z values per location. It stores one Z per XY location. It is discrete and it is vector.
Option B, sir.
Yes. Next is which is suitable for normal nominal data interpolation. So we have nominal data. So what is nominal data first of all? Anyone? So we have learned the different types, the nominal, ratio, interval, and when we are doing this thing, interpolation, mostly our data should be interval and ratio. So in the IDW and all, we have learned that if our data are not numeric data, then it will create a problem. Okay, let's show one more. But when we are doing this thing with the Thiessen polygon, then it can be useful for the nominal data as well, because it just constructs the polygons and associate the same value when these polygons are matching. So it's a local exact method, means it means same value. Abrupt changing means if you are going from one point to another, it's just abruptly changing, and deterministic means it just gives one value, not the uncertainty associated with it. And that's why it is a good method for nominal data. Oh, sorry. Yeah, so that's the wrong answer. It should be Thiessen. Age effects in interpolation arise due to, so there is a age effects in interpolations arise due to lack of data at margins, basically the issue of age. The next question is in kriging, uncertainty surface provides projection error, standard error of prediction, DEM roughness, and spatial resolution. So it provides the standard error of prediction. Next question is which is deterministic, which interpolation is deterministic, but it is approximate. Spline, IDW, kriging, and Thiessen.
Option B, sir.
Option B, it's not correct. Why? Because see, if you see IDW, then if our point is, whenever our point is there, we will get exact value. Okay. Because like the nearest point from our point should be the same only. So wherever our points are there, we'll get the same values. So IDW should not be the answer. Okay. Similarly, Thiessen, we saw that Thiessen is deterministic, local, exact. So deterministic, local, and exact. So Thiessen is not the answer. So correct answer here is spline interpolation, which is deterministic, like we'll get the exact value, but it's approximate. Data reduction and generalizations are required primarily because of GIS cannot handle large data, small scale maps requires abstraction, projection errors increases, raster format is large.
Option D, sir.
Raster format is large. Okay, that is also true, but if we see here, like the correct answer should be small scale maps requires abstraction, because like as we are going through like changing the scale, it should not have too much details. Okay, so that's why we need generalization, because as we are going, like it's not just raster format is very large. Even if we have just vector data sets, we need to do reduction and generalization. As we are going towards one scale to another scale, it should go down. So basically the thing I think we have seen here in the, I think we'll see in the quiz only later on. So it should be this answer. Now next one is rectification and georeferencing ensures topographic integrity, radiometric correction, spatial alignment to coordinate system. So its georeferencing is alignment.
C.
Yes. Which method minimizes overall surface curvature? IDW, regularized spline, trend, and Thiessen.
Option B, sir.
Option B, let's see. I don't think so, because regularized span. Okay, okay, got it. We just discussed that. Regularized and tension span, which will minimize the overall surface curvatures, and one is the steep one. Okay, next one is which method can be global, local, smooth, or abrupt depending on the model. So it's a kind of kriging, because in kriging we have multiple methods available: nominal kriging, ordinary kriging, local kriging. So it depends on which kriging method we are using. It might be anything. In IDW, limiting maximum number of points will improve the correlation, reduce the processing time, increase the smoothing, and converts to global method.
Improves correlation.
Yes. Limiting maximum number of points. So we should not use more than 100 points. So in general, what will IDW will do? It will consider all point, and based on that, it will do the calculation considering the distance of each and every point. But now let's say we have specified that now we will use 100 points only. So what will happen? Like correlation, we don't know that whether as we are increasing distance, the points which are further away, they have high correlation or less correlation. But one thing will happen definitely, that it will reduce the processing time, because we are taking less number of points. Okay, so correct option should be option number B rather than A. A contour line joins equal slope, equal direction.
Equalization.
Yes. Functional surfaces are continuous because of they store random values, they assume one value per location, they are vector, they ignore trends. So basically they assumes one
A.
value, yeah, per location. The next one is which is not a classification of interpolation method: local versus global, exact versus approximate, deterministic versus
That's the this
versus
is
vector.
vector.
Okay. The next one is identify the generalization method. So here, this is the polygon or the data sets which we have, and these are the different methods A, B, C, and D. So you have to identify which one is the correct. So A is elimination. Is it correct?
False.
Yes.
Wrong.
B is size reduction.
False. False, sir.
False. C is displacement.
True, sir.
Yes.
Okay. But I think C, if you see, it's a kind of size reduction. See, size
Mm-hmm.
reduction and combination of two. And the D1 is size reduction. That
True,
is
sir.
true. Next is identify the error in this given polygons. Dangle, knot, overshoot, or silver.
Option
Silver.
Yes, option number
D.
D.
D. It's known as silver. So for polygon, we have overlapping and silver. For line data, we have dangle, overshoot, undershoot, knot, loop, etc. The next one is identify the error. So here you can see two images are there. So you have to identify which error it is showing. A respectively. Overshoot, undershoot, undershoot, overshoot, dangle and knot, knot and dangle.
Option B, sir.
Shoot.
B.
And
Undershoot and overshoot. Yes, true. Identify the parts of semi-variogram. So here the various parts are given. So you have to identify which one of the following is correct. The A is known as a sill, B is range, E is nugget, and D is distance. D is over here. So which of the following is correct name? So here correct option is D is distance. If you know, this is known as a partial sill. This is sill, this is nugget, this is the range, and then this one is the distance. Or else I will show you the figure so you will get more idea about it. So when you use breaking, so this is partial sill, nugget, range, sill, and distance. So these are the various parts of the semi-variogram. Okay, so thank you everyone for joining for this quiz. Now we'll start with the QGIS session. Now I have changed some visualization compared to the previously. So I mean, and I tried to show the corresponding lecture slides also so that you will get to know that whether where it was covered in the class. So I think is it fine or should we do with the previously what we are doing?
no, sir, this is fine.
Okay. So next time also we'll try to do like that. So if some questions are difficult or if explanation is needed, I will show the corresponding slide only rather than talking me so that you will get some more idea and it will get you referenced also for exams as well. And you can revisit the same stuff again as well. Okay. Yeah, so that's it. And just please go through the questions here. Like the content is too much, so I cannot cover everything, every statement in the questions. I try my maximum to cover the most of the questions, but still there are couple of very good lectures, concepts which are given here in the all the videos. There will be a couple of numericals as well in the interpolation. You will find that in GATE exams as well in geomatics or civil engineering. So please do solve those questions also and read about the interpolations method as well. Okay, so with this we'll do this uh, this MCQ session is over. Now today we will learn about this interpolation. So for that we will use groundwater level data sets. So for that there is one site known as Atal Yojana, Atal Bhujal Yojana, which is from Department of Water Resource River Development in Ganga Regeneration, Ministry of Jal Shakti. So I'll just show you about this website, what they do first of all. So first of all, anyone is working with the groundwater or potential of groundwater or anything related to the groundwater?
So not working but yet, but I'm going for a workshop.
Okay, so yeah, this will be very helpful to you. So what we can see is like this site, basically this description, strategy, what they are collecting, everything is given here. And basically in this data disclosure tab, we will have two information. One is related to water level and one is related to the water quality. And there will be other areas like various kind of geological, hydrogeological reports are also given. And what are the areas which are covered under Atal Bhujal Yojana. So basically, if we see area under this Atal Bhujal Yojana, then let's say just select it and we just download this PDF. So here is the name of various villages, basically Gram Panchayat level. So basically, this particular scheme is currently being implemented in the 7 different states: Gujarat, Haryana, Karnataka, Madhya Pradesh, Maharashtra, Rajasthan, and Uttar Pradesh. In that also, it is not covering entire state. It covers the specific districts and specific block only, which you can show here. And the details about those state, districts, and blocks are in Gram Panchayat are given here. So this data are the known spatial data. It's just in terms of table. But if you want to cover this thing on a map, then you can just have a shape file which will represent all the Gram Panchayat level informations, and you make connect this table with your shape file and you can show it in map as well, that which part it is showing. Okay, so that is one thing. Now we'll see hydrogeological reports as well. So here, let's say if we take anything and let's say in Gujarat. So currently I'm in Gandhinagar, so I will check some reports of Gandhinagar. So basically I want to show what kind of information using GIS they are providing here. So this is first is like hydrogeological report of the given block, district, and in which year it is being prepared. And then the further details about number of gram panchayat under this particular block, then number of town, villages, male population, female population, overall population, how much rainfall is happening, and then land use details, crop details, soil details, how much area is under irrigation. So all the details you will get. And then after like different kinds of aquifer. So aquifer is the underground structure where the water is being stored. Unconfined and confined aquifer. If you are civil engineering background, you should know this terminologies. Uh, and then like how many wells they have used for this water level monitoring or the water quality monitoring and from which aquifer. So all those details are given here, and once all this after all these details they have given the different maps. So in the previous lecture we were talking about like how to generate map and which kind of uh, elements map should have. So here you can see that we have like various coordinates, then north direction, then scale, legends, and then map data along with the title. And then these are the specifically a location area map where we represents the larger to smaller perspective, that we have site located in Gujarat, in that in Gandhinagar, so it's like highlighted by yellow. In Gandhinagar, there are 4 sub-districts. So this map is currently representing the Dahegam. In Gandhinagar district, sub-district is Dahegam, and that Dahegam map is shown here, where you can see the different monitoring stations by Atal, then Groundwater Board, CGWB, Central Groundwater Board. This is Gujarat Water Resource Development Committee, like from Gujarat Board, basically Gujarat Water Resource Board. Then this is the railway network, district roads, state highways, and river and water bodies. So basically, this one is the Sabarmati River, and then the canals which is passing from here. So there is the Narmada Canal, Taluka boundary, and village boundary. Okay, so this informations we are getting here. Now, other map, it is showing the hydrogeological map of the Egam Taluka. So where it is showing the depth to water levels pre-monsoon. So pre-monsoon, what is the depth of water level? If I want to find groundwater here, at what depth it is available. So you can see at 10, 20. So these are being as a contour. And in quiz also we discuss contours are the line joining the equal elevation. So here instead of elevation, it is a depth, groundwater depth. so at which it is available, and this red color is electric conductivity of the available groundwater. So you can see this zone, the groundwater is like available at very shallow depth, whereas in this region it's available at greater depth. So why that is happening, why here also it's like that, so those things you can answer. Now these are the some of the cross section. So basically how this confined and unconfined aquifer will look like, what kind of material it have on the top and bottom. So all those informations, and this is the further maps which you can prepare also. Now here you can see they have used this IDW interpolation method. So they have this data of all the points where these blue color points are there. And then after they used this IDW interpolation on the depth to water level for the pre-monsoon season, and they generated this kind of maps. Okay, so here you can see, so this is the pre-monsoon and same the post-monsoon. So you can compare these two maps after on further on, that what happens when we go from pre-monsoon to post-monsoon, which are the parts where the rainfall is getting filled or it is getting recharged, or which are the location which where the recharge is not happening because of XYZ region. And then after you can see these maps are for electric conductivity, and then these are the actual latitude longitude of those wells and their details. Now this data, if we want to convert into geospatial data set, then we have latitude and longitude information with us, through which we can directly import this data into QGIS, RGS or any GIS platforms, and this other part or other parameters will becomes our attribute, which are the non-spatial data, which will show the type of aquifer or what kind of station we have or what is the reduced level. So all those information will shown by the different attributes which are presented here. So whatever the wells are represented there, all the lat long information you will get here. And then after you will get pre-monsoon, post-monsoon depth of water level. So at the given water level across the different year during pre-monsoon and post-monsoon season, when the data is being collected, what was the depth of water level. So that thing you can see from these tables, and then you can compile this thing everything and make a generalized data set for. Any doubt till now? So like this is one application of how we can use this groundwater GIS for this groundwater level data sets. Now if we want to download this data by ourselves, this data which are shown in the table format, then we can click on water level or water quality depending on which data we need. So let's say currently I'm interested in water level data set. Now I will click on Gujarat and I will download this Excel sheet. So now you will think that the data which we have downloaded are as an Excel sheet, but how can we convert the data into as a GIS ready files? So that we will learn today in the GIS section. So yeah, let me download it. Yeah, just download it. So currently we are in. Okay, first of all, we'll see the how our data looks like, and the file name is also weird, so you can change the file name as well. Okay, so we have data like this. Okay, now the only thing which we have is latitude and longitude information, and then we have pre-monsoon, post-monsoon, 15, 16, 17, 18. So different year, pre-monsoon and post-monsoon, what is happening. And you can see like most of the data is available in the year of 23 and 24. Okay. Yeah. So that is the data, and I will just change the file name groundwater depth QGIS. Okay. So before moving forward, any question, anyone till this point? Anyone, any question till this point? So what we have learned till now after the submitting our quiz, we've gone through this Atal Jal site, which can be useful for groundwater monitoring. It is currently being implemented, this scheme, in the 7 different states across the India. Uh, and this data are available through this particular site. So these are available in Gujarat, Haryana, Karnataka, Madhya Pradesh, Maharashtra, Rajasthan, and UP. I will just give you this site also, so that if you want to look into by yourself, you can also do the same. Okay, so we explored the various.
One doubt. So this is
Yes,
available for seven countries. No, not seven
7
states.
states.
So other states for the informational for all.
Yes, so they are not covered under this Atal Jal mission. They
Uh-huh.
are covered under CGWB. So for that, what you can do is, for if you need that same data for other site or other state, you can go to India Vari site. Uh, Basically, this is the site of government water resource department.
Uh-huh.
Yeah, this site is very slow, and I don't know. You
Mm-hmm.
have to find a proper time when these data are available. So, I mean, in this, there is a geospatial data tab under which groundwater depth data is available. So there they will have all the station data sets. Apart from
Okay.
that, there is another site which is known as the data.gov.in. So this is also government site for Indian data sets. Here also, if you go to search, um, so here, if you write groundwater, so here also you will see the different data sets. So year-wise groundwater data for Tamil Nadu from 2019 to 2021. Uh, State and union territory wise groundwater resources and their extraction. So there are various steps are there. So you can go and check out which data. But yeah, these data are very scattered. On Atal Jal, water data are available. They are like available properly. So you can go here and download it in Excel file. You can just give your details and fill the data. And another thing is this India Varis portal, where you also data download, and then you can go to geospatial data or else water data and groundwater data, and you can just like there are different tabs available here as well. And then data download, geospatial data. Here also various tabs are available related to the different features which are there. So here you will get data related to the lithology, groundwater layers. So basically this is the groundwater layer. If you will say here, so here the depth of first aquifers, depth of second aquifer thickness, all those data are given. If you need a time series data like water level or water quality, then you can go to this time series data sets. Here you can select groundwater levels, and then you can select the administrative like admin level data or CGWB data, and then select state, districts, and all those things, and you download the data sets afterward. But this will take time, so you have to just figure it out. Okay.
Okay.
Yeah, so these three sites are there currently as of now, and there are some of the researchers who have also converted the data by themselves. So I think we will also publish some of the data related to groundwater in the next few months. Once that is been out, I will share it with you all so that you can use it for your research as well. Okay. Any other questions? Okay, if there is no other questions, what we can do is we can now move towards the. So I think we'll move towards the GIS part now. So first of all, we want to import these data sets into our QGIS window, whatever we have downloaded. Okay, so for that, what we'll do, there is a button add layers. Now here we'll click on delimited text because our data is as a text file, not as a vector file or raster file. Then we'll click on these three dots. We'll go to the particular folder where we have kept our data set. So my data is under course GIS. So your file should be a CSV file. Okay, if that is not CSV file, then it will not allow. So if please check what file format you have. So currently it's Excel worksheet. That's why it is not showing me under my GIS tab. So for that, what I will do, I will just save this file as a CSV file. So I will just go to file, save as, and the same file, I will save it as a CSV file. Okay. So now my file is CSV file. Now I can go to QGIS and open that file. So now it is showing here. Okay, so now we can go towards the, like we have selected our file. Then after here you can see this is the CSV file. Then if you have normal text file delimited by space or commas, then you can select this also. Now records and field options. So number of header lines to be discarded. If you have some few lines as just nothing is there, then you can discard those lines as well. You can provide the separator as well. So those details you can provide. Then which is the point coordinate, basically X field and Y field. So our X is longitude and Y is latitude. And then our data are in degree decimal. So the coordinate system which you can select is 4326 WGS 1884, which is a geographic coordinate system. And then after you can click on add. So it will plot all the data sets. Now how do we know from which part the data is? So what can we do here? Now it's from Gujarat, but like from where in Gujarat?
We
So
can
how
add
do
the base map.
Yes, exactly. So next step is to have a base map. So I will go to base map. So this is the one of the plugin which I have installed in the previous lectures. I will just go here and just add any base map. So let's say I will just add Google Maps. And you can see this currently the monitoring region is some parts in the Kutch and this part. Okay. Now, so this is the area near IT Gandhinagar, and here you can see various points are there. Now, what kind of things are there inside this point? What kind of attributes are there? So for that, right click and go to the attribute table. Okay. So here you can see there are various attributes. The first one is the number, then the name with its LGD code, then the name of the particular district, then the name of block, then we have name of Gram Panchayat, then we name a village, site name, type, which kind of type of well is there, latitude, longitude, depth, aquifer, then the data point. Okay, so we have this much data sets with us. Now let's say if you just need a data for let's say Gandhinagar only. Okay, let's say Gandhinagar 446. So we have data for all the Gujarat, which is this part, but we need data for just Gandhinagar region only. So there are a couple of tools through which you can extract your data sets. And this thing also you will learn in the previous next classes once you start learning the GIS analysis. But I think this is necessary at this point of time. So I will cover this just small thing. So here the various tools are available for vector analysis and vector selection. So I will go to vector selection and I want to just extract the data by some attribute or some expression. So what I will write a expression here. So basically I want to use field as a district name. Okay. Or else let's say we'll go block wise only. So I want to write something on block wise and all unique. And here let's say the Hegam or let's say Gandhinagar. Okay, so here you can search the various values which are available. Now block name with LGD code should equal to Gandhinagar. So this is the equation which we have written here or the formula which we have written here. It means that block name with LSG code means whatever this column name is there, it should equal to Gandhinagar underscore 3775. And if this condition is true, then it will give us all the matching features. So that we want to save. So let's say Gandhinagar groundwater depth. And I will run this algorithm. So now you can see I just got the points around the Gandhinagar. Is everything okay till this point? So from site, we have downloaded the data of entire Gujarat. Similarly, you can download as a entirely like data of entire India. And from that also you can do this partial filtering. They have given the different state-wise because if they will give entire data and if your system is not able to handle it, then it will become problematic or it will start lagging. So we got the data set. Okay, but this data is point data, which is a vector data. And we want to convert this into raster data showing the groundwater depth map. Okay, so for that, what we have to do here? So I will repeat my question again. We have these data sets which are as a point data. Now we want to generate a groundwater depth map. So basically for map, what we need a contour or we need a raster layer. Because
You have to
from,
interpolate.
yes, we have to do interpolation. So we'll start with the IDW interpolation. Inverse distance weight. Now this is the interpolation way. Now here, this is the file which I'm using, which is Gandhinagar groundwater depth. Interpolation attribute, which parameter of the attribute table you want to interpolate. So we have this many parameter which are numerical, or it's given that this will work when we have ratio or interval data. If we have any attribute which is nominal, then this will not work. Okay, here the aquifer details, whether it's unconfined, confined, those variables were also there, but it has selected all the variables which has numerical details, or you can say ratio or interval data sets. So what we want to do is, let's say we will do pre and post 2021. So I will select first for pre 2021. Then after I will click on plus sign. Okay, and then I currently have points. If you have structural lines, break lines, then you can represent that as well. So currently these points which I am representing, these are my point. If you have any other layer which you want to represent as a break line or structure line, then you can represent that as well. Then we have distance coefficient P, which was we are talking about as a power in IDWD. So currently by default it uses the power of 2, and as we discussed, if we increase the power it will preserve the local details, and if we reduce it, then it will make the surface generalized or the smooth. Now extent means in which region you want to do interpolation. So basically there are options that calculate from the layer. So wherever my points are there, do the interpolation around that only. Otherwise, calculate from layout map and calculate from bookmark, or you can draw on map canvas also, that perform the interpolation on this entire region, because IDW interpolation it will do outside also, because what it has to do is it has just have to find the nearby point. It doesn't matter where it is, so it can be useful as an extrapolation method also, not the interpolation. Okay, so either you can select that or you can select the calculate from the layer and the selected layer which you are giving as your point. Now you have to specify when you are converting your data from vector to raster. So you obviously you are generating a raster. Okay, so what pixel size it should have. So you learned about the degree in a meter conversion. That 1 degree is equivalent to 111 kilometer, and then we have learned about the 10 arc second, 3 arc second, 1 by 3 arc second. So what kind of resolution you want to keep here, that you have to specify. So here I will keep 0.1 as of now, so that it will become fast, otherwise it will take time. And then you have to save the file, which is the interpolation layer. So this is the pre-monsoon 2021 Gandhinagar groundwater depth. So give the proper name in such a way that you will able to identify it later on. And here you can see it is saving my file as a SDAT file. You can also, there are multiple formats are available. You can save it as a TIFF file also and save. And then I will run this algorithm. Now you can see it has interpolated my surface. Okay, any doubt till this point? Anyone, any doubt till this point? Okay, so after this we will do the post 2021. The same thing with post 2021. So I will just select this. Okay, interpolation attribute we have to select. Okay, otherwise it will just do the number. So we want post 2021. I will add plus sign, distance matrix 2 only, extent use from the given layer only. This one is 0.01, and then I will save it as a, instead of pre I will use post. Okay, and then click on run. So it has generated another layer, pre and post. Now let's say we have to keep the same color for both. Okay, so we'll get to know that both are similar or different. Okay, because from here it's not making much sense. Okay, so we'll just do the quick thing and we'll just check out the. So what we'll do is we'll go to property and we will go to symbology. Okay, and here we can represent the single band pseudo color. Okay, and then after in this groundwater, so we can represent as a spectral if higher ground table, then blue color, lesser. So these are the groundwater depth. So if the greater the depth will represent as a red color. So I just want to invert it. And we'll represent from 10 to 100, let's say. Okay, so this is 10 to 100. And to apply same symbology to, so I will just go to right click, style, copy style and symbology, and I apply the same symbology to this layer as well. So layer style and paste style and symbology. So it will apply the same color to the my map also. So you can see there is a little bit variation which we can see, but not that much difference from these two map. Okay, so there is not much variation which has happened pre and post 2021. And if we want to see that as well from, we can check the attribute table also. And we can see 2021 pre and post. So if we see, there is very less variations which is visible, but still like variation of 1 or 2 meter is still there. And you see most of the location datas are not available. But if you see this 23 and 24, this datas are available. Now, do you guys have any questions here? See, otherwise I can ask. So when we do this interpolation, okay, we see here pre, post. Okay, anyone has any issue till this point, first of all? Are you guys getting what I'm saying? Like how you can monitor the groundwater level pre-monsoon, post-monsoon. You can convert the point data into raster data and then calculate the change. Any question till this point?
So you're mute.
Okay. Are you able to hear me? Uh, I think my mic is on only. Are you able to hear me? Hmm. Can anyone confirm? Are you guys able to hear me? Can anyone confirm? Are you guys able to hear me? Okay. Um, am I audible here now?
Yes, yes.
Okay. Uh, so till which point I was not audible? I mean, can anyone confirm it again? So I can repeat those things. Can anyone confirm at which point you lost my voice?
We have heard about your post groundwater interpolation.
Okay, fine. So we have done pre and post interpolation of groundwater levels. Now, what we want to see, like, do you guys have any question till this point? Otherwise, I will ask one question to you all. Okay, I think if you have any question, then I will ask. So my question is, when we are doing this IDW interpolation, here you can see the layers which it is showing me to interpolate. So here I can see the layer of pre 2021, post 2021. But for 2022 and 2023, I'm not getting both layer. I'm just getting post 2022 and pre 2023. But pre 2022 and post 2023 layer, I'm not able to here. So first, let me check that do we have those layers or not. So if I see the attribute table, you can see here clearly that I have layer of 23 pre and post also, 24 pre and post also. But somehow these are not available. So what might be the reason? Because see, this same thing will happen with you when you will start doing. You will download the data from government sites and you will try to do the analysis, but you will stuck with the same problem. So what is the issue here?
Nearest values are available.
Yes?
Only nearest values are available for interpolation.
No, what I'm saying is this columns, these attributes, they are not available for interpolation. This pre-post 2021 is available, all these layers. But
Those
this,
columns are showing us string values. So string values
yes, exactly,
cannot
exactly,
be interpolated through
exactly,
IDW.
exactly. So from data, you will see that as a ratio or interval data. But if you see each and every value of that layer, if you can just click here, okay, so now if I see here, there are multiple values in this. So basically, if you see this post 2023 column, there is no string. But if you see this pre 2024, then there are lots of value with the name like not approachable, filled up, DWLR installed, drive well. So this thing will not work because when we have to do interpolation, it should have a all numerical value only, not some values are string, some values are numbers. So how you can solve this problem? Any idea? Any idea how will you solve this problem? Or any
We
guess?
can replace those strings with zero
Yes.
or null.
Yes. So zero we cannot do because we don't know whether it's actually has zero or not. Okay. So one thing what we can do is here null we can write. On the other hand, what do we have here? These wells are dry well. Okay, it means they are completely dry and there is no water available in it. So what we can see if we have the well depth data. Okay, so this depth of this well is 245. So if it is dry, it means this entire 245 meter is dried. So we can replace those value over here. Okay, if it is dry. Cover up means the station got covered up with something, some material, debris or something else. So here what we can do is we can write null. So what you can do is you can use this editing toolbar and then you can generate the data like null. And wherever the dry is there, you can just replace the values which are given here as a well depth. So these steps will become a pre-processing steps. Before starting your GIS, you have to see each and every attributes, whether they are numeric or not. And good thing, how you can check those variables are, you can go to properties and in properties, if you scroll it down, you will see the fields, okay, and the data type. If the data type which we want to use it here, post 2033 or pre 2024, they are having string data type also, and that's why we are not able to interpolate that particular attribute. So you convert this string into a number by removing the variables which you have there. Okay, so this way you have to do the pre-processing to your data sets removal data and making it correct before doing the analysis. Okay, so that is one point you should remember everyone. Now next thing is, let's say if you want to plot contour here instead of this maps. So for that, what you can do is you can just write contour here, contour, or you can put your input layer as my, let's say I will put my pre 2020 layer, and the groundwater depth is changing from let's say 0 to, or let's say 10 to 100. So I will keep a contour line at every 10 meter or 20 meter. So groundwater depth, and then I will just run it. I will not save this, I will just run it. So just put it on the top. So you will get this contour line. So basically, okay. And then after the same contour lines, if you want to show, so basically, so this we have plotted for pre. Now this contour line, if you want to show the numbers, I will go to property, then symbology, and then you can see here labels are there. So labels, we'll use single labels, and then we will use groundwater depth. We'll use OK. So those labels will come over here. Okay, now we can change the color of those contours. So instead of pink, we'll make it black so it will be visible properly. Okay. Now, if you want to improve this labeling also, you can right click, go to symbology, click on the label, and then you can add the buffer around it. So it will make it look good like this. Okay. So like this you can improve. Now you can see the raster which we have on the back. It has not color as our contour. So if you want to represent the raster also as a contour map, or you can say the colors which you can see in the raster, you also want to show it as a changing with contour. So for that, what you can do is we have to change the symbology again. Instead of single band pseudo color, what you can do is you can select the, instead of here continuous, you can show the equal interval. Okay. Or how many classes do you need? 10 classes. So this will become like this, but still it is a changing, like from 10 to 20 if you go, the colors will change. So if you want to avoid that, what you can do is you can use paletted and unique values. So it will use the palette and then multi-band colors, single colors, and then contours. So contour if you will use, so it will show you this contour colors basically. Okay, so here the same way, like we have represented the contour, you can represent the contour symbology as well. Second thing, this is single band pseudo color. Here also you can, instead of linear, like the interpolation between two color, rather than keeping as a linear, if you will keep it as a discrete, then it will show you the range. Okay, so the range which we have given in the contour and which we have given it here, that also you can make. So basically, let's say here I will say the value should be 20, then 30, so after 30 we'll go to 40. So we'll say use the same values as we have used for contours, 60, 60 to 70, 70 to 80, 80 to 90, 90 to 100, and more than 100. Okay, and then I will click on apply and okay. So now you can see we got a class like this. Okay, it's it's not changing in between. If the value is between 60 to 70, it will just show the one color only, not the multiple colors. And you can see, like when we are converting this raster data to vector data, this generalization is not proper, or you can say the conversion is not capturing entire biome boundary, smoother line, because this is the loss which we are getting. Okay, so if you have higher resolution data instead of 0.01, if we will interpolate with 0.001, then you might get this boundaries as a smoother boundary because of multiple polygons. And similarly, like after doing this, you will get the same map. You can just change a little bit color here and there, and you will get with the same maps which you have seen in this hydrometric report. So the government agency, specifically CGWD, they do the same process to map the groundwater level pre and post monsoon. And then after they publish a map like this with all the other data sets, what was the well locations and all. Okay, so here you can see the colors here, and you can place the same color in your window. So you can generate exactly same map. And then after you already know that how to prepare map according using this, so that we have learned in the previous class. If you don't know, then you can go there and check. Okay. Any doubt till this point? Any doubt till this point? Okay, so this is a classic application where we use interpolation. But let's say, how do we know that whatever the interpolation we are doing, that is right or wrong? So for that, what we do is, before doing the interpolation, we will take out some data set. Let's say if we have 100 points, 70% point we will use for interpolation, and 30% point we'll keep it for the validation. Once we get all the interpolation done, wherever we have points, we will go there and we will check that whatever the results which we are getting, they are right or wrong. So basically, I will go at this pixel. Okay, now I will check it here. Let's say at this pixel I went. Okay, my pixel density I will see. So that is 77.99. So I will getting around 80 value. And if I will see for this pixel, so for that pixel pre-monsoon 2021, sorry, is null. I mean, there is no value associated at this location. Let me check some other where we have data value with us. So here also we do not have. So you can see there are very less points which are available. Now if I want to see where these points are available, I will just search it from here, select, highlight it a little bit. Okay, this pixel we do have value. Okay, so this pixel, the value is for 2021 is around 88.79, or you can say it's 88.8. And if we see the pixels which are there, so it is having 85, and the pixel which is here, it is having 87. Here it's 88.3, here it's 87.3. So it is considered the weightage of the nearby pixels also, the which is this one, this one, this one, this one, as well, like this. Okay, and based on that it has given value. So actually it should have the value of 88.8, but if you see the nearby pixel, it is 85, 87.93. So this is near to 88.8. Similarly, this is also very near to 88.32. So it's 88.8, it's very near. There is less error is available, and as you go up, it will give less weight to it, and the values will vanish. Further, if you will go more, the value will vanish more. Okay. Yeah. Any doubt? Similarly, we can check it at this pixels also. So here the value is 93.68 and the pixel which we have is around 106 and 105. Why so? Because at this location we may have more than one point available. See, when I'm clicking here, more than one points are having same latitude and longitude, and all of them might be having different data sets with them. So it same location, it has different values of pre and post. So this is also an error in the input data only. So that also you have to correct while doing the pre-processing. So these are the things which you can learn as you will do. Okay. And now let me show what kind of other interpolation methods do we have in this, because we cannot do each and every. So for kriging, we will have ordinary kriging, regression kriging, simple kriging, universal kriging algorithm available in QGIS. Ordinary kriging, you can select the point, attribute which you want to do interpolation, cell size, fit, error, how do you want to calculate error, standard deviation or variance, the distance, how much distance do you want to consider, then which model, linear model do you want to use or any other model you want to use. So that will block cross validations, global, whether you want to make a global model or local model. That also you can specify, as we learned in the lecture. It can become anything depending on which model you are using. So you add all the details and do the thing. Then there is a regression kriging which will use this regression, where resampling will be done using various algorithms such as nearest neighbor, bilinear, bicubic, and B-spline, which we have learned in the previous classes. This is the variogram model, and this is simple kriging and ordinary kriging, and then local, global. So most of the options will be same, and then you will get additional options such as prediction error, regression models, regression coefficients, and all. Then you have simple kriging and universal kriging. Now, apart from that, you have also spline interpolation. So B-spline interpolation is there, RST interpolation is there, RST CV interpolation is there, cubic interpolation is there. Okay, so this V dot surf B-spline. So this is the bicubic or bilinear spile interpolation with the Tychonow regularization. So we are using the regularization terms also here. Here also we have bilinear and bicubic, which kind of things we want to do. And these are the other parameters which are associated with it. So these are the again other some of the interpolation. This is the TIN interpolation is thin plate spline, and then TIN interpolation is also available. TIN, triangular irregular network. So yeah, it might be there somewhere here already. Yeah, so that this is the TIN interpolation, which is also similar to this IDW only. You have to just select the interpolation method, linear or cubic, and then that's it, done. So nothing else here. Yeah. So you can use various methods and you can check out how you are getting the interpolation results. So that was for today's class. I mean, we have discussed a lot of interpolation applications, not just in MCQs, but in the actual data with the groundwater level. Now, if you are interested, you can do the same thing with the temperature data, rainfall data, elevation data sets, and try to interpolate various stuffs. Apart from that, if you are interested, you can extract the data from your DEM first of all, and you can try to reinterpolate the same DEM, whether you are able to regenerate the same or not. You can try with that as well. So those things you can do by yourself. Any question? Do you guys have any questions for our lecture or the previous week content?
Okay, I have a query. You
Yes.
have shown us all type of interpolations, but what about that Thason polygon interpolation? Is it available in QGIS
Yes,
or
yes,
not?
yes. That is also available. I think so. It's available. I have not used it, but it's available. I will check. So, so one is this Voronoi polygon is also available if you want to use. Um, see this one. This is kind of Thyssen only. Okay, this name is different. This Voronoi. This is similar. Okay, I think you are not able to see my screen. Let me share it again. So in QGIS, the name of the method is this Voronoi polygons rather than Thyssen polygon. The name of the tool is different. It's same only. Okay, this one. Generate a polygon layer containing the Voronoi diagram corresponding to the input points. You have to give the points, buffer region, tolerance level, and then it will generate the polygons. I think we can try it out. So these are the Thyssen polygons for the points which we have. Is that fine?
Yes, yes.
Yes. Anything else? Any other questions? Anyone? Okay, I think hope you are enjoying these classes. So from next 2 weeks we will have GIS analysis thing. So what we will do is we will try to solve some real life case studies issues taking the data of Delhi or some other regions which I already shared with you in the this attendance sheet and the sheet where from where you can access all the lectures. So next two labs or next two doubt sessions, we will try to solve a couple of examples using the data given in that. Uh, Doing the basically overall analysis, how it can be helped, whether it's a buffer, proximal, data selection, extraction. So all those things we will see. If you need any other guidance, any other things which you want to learn in QGIS, please let me know in through my mail or to NPTEL Q&A session or the Q&A portal, or you can just write it me here as well. So I will try to cover when we have that same thing aligning with our content from our NPTEL class. Okay, so if you have anything, then let me know. I will take your mm, like advice and suggestions and try to incorporate that. Uh, if there is no other question, then I will end this session. Thank you everyone for joining. Thank you. Bye bye.